Hi, welcome to Chapter 4, Section 10, the last section in Chapter 4. We're going to talk about scale models and drawings. So I'm going to throw a few definitions out at you first. First, a scale model is a proportional, three-dimensional model of something. Usually it's smaller. A scale drawing is a proportional, two-dimensional drawing of something, but both words proportional are really important, and that's why they're in this chapter, because it's all about proportions. The scale and the scale factor, this is the ratio between the two, the drawing or model and the actual object. So for example here, we've got a photograph. And I have a photograph here that is 6 inches by 4 inches. And I want to make this photograph into a poster. And I want this poster to be 27 inches tall. How wide is it going to be? Well, because these two are proportional, I can actually figure this out. I can set up my proportion. This is going to be 4 by 6, and this is going to be, and the width and the length have to be on the same side. So if I'm going to go width by height, then I'm going to go width by height. And now, cross multiplication will help me solve this problem. I can go 27 times 4 equals 6x. 27 times 4, that's an 8. That's 108 equals 6x. I can divide each side by 6. And 108 divided by 6, 48. 8 times x equals 18. So this is going to be 18 inches wide. Same goes for models. I have a little model sailboat that's 24 inches tall and 18 inches long. Now I have to fit this into my garage, but I'm building a special garage for it. I know that I want it to be 15 feet long, but how tall do I have to build my garage? Well, let's set up a proportion. I'm going to go height over length and height over length. So, let's see. I know that 24 times 15 equals 18x. 24 times 15, 10, 12, 24, 6, 3. So 360 equals 18x. I'm going to divide each side by 18. And 360 divided by 18, that's 2, and that's 0. Woohoo! X equals 20. So I know that it is going to be 20 feet tall. Setting up your proportions makes it really easy to do this. So this is using similar figures, what we just finished, but even more in the real world now, because we can do it with real things as well. Now, sometimes they ask you to actually find the scale factor or use the scale factor. For example, we have a photo that is 5.4 centimeters by 4 centimeters. And it has a scale factor of 1 to 15. I'm going to make a poster out of it. What is the size of the poster going to be? So I've kind of drawn a diagram here because pictures help me see stuff. And if my picture is 5.4 centimeters tall and 4 centimeters wide, and the scale factor is 1 to 15, I want this 15 times bigger than my picture. What is the size of the poster? So what I want to do is I want to think about, okay, my small one is 1 and the big one is 15. So it's the photo over the poster. I have to change both things. So this is actually 2 math problems. When you have the scale factor and it asks you the size of the poster and it doesn't give you any, you have to do both of them. So it's, what is this one to 1 over 15, and what is this one? So photo over poster is 1 over 15 because the poster is the big one. So what do I have? I've got that the photo is 5.4 centimeters. It's this to this and this to this. I want to make this size. I want to make this size, and I've got to go through 1 over 15 to get it. And by setting it up this way, you know if you are going to multiply it or you're going to divide it. You have to set it up like this. So here I know that 5.4 times 15 equals 1h. So all I have to do here is multiply 5.4 times 15 to get this size. And 5.4 times 15 is 810 with a decimal point. 81 centimeters tall. And this one, 4 times 15 equals 1W. So I know that the width is going to be 60 centimeters because I can do that in my head. When you're making it smaller, if I tell you I had a poster and these are the dimensions of the poster, and I need you to find the dimensions of the postcard that we're going to make out of this, if the scale is 1 to 15, then you would have ended up dividing. Then you would have ended up with, let's see, I've got 81, and I don't know how high it's going to be. And so now my 81 and my 115 look like this. You would have ended up 15 times h equals 81 times 1, and you would have ended up having to divide. So setting them up in proportions helps you find out what operation you're using. And if it's not 1 to 15, let's say it's 3 to 10 or something, some odd set of numbers, it'll help you figure out what you're multiplying by and what you're dividing by. Okay? On a map, the scale, every 3 centimeters on the map is 128 kilometers. The cities on the map measure 10.5 centimeters apart. What is the actual distance? So we need to set up a proportion here. So we're going to think map distance over actual distance. Map distance over actual distance. So here our scale factor does not start with a 1. So it's not going to be this easy. It's not going to be just multiply them. You actually have to set up a proportion. So our 3 over 28, we have to figure out what our 10.5 means. So our 10.5, is our 10.5 the distance in the actual world, or is it the distance on the map? 10.5 is the centimeters on the map. So we have to put it on the top, and the actual distance is going to be on the bottom. So we've matched up the scale factor with map distance, actual distance, map distance, actual distance. This is the one we don't know. So now we can cross multiply. 3 times d equals 128 times 10.5. And this shows you the way to do the math. And now you can follow through with this problem. You can do 128 by 10.5, and then you divide both sides by 3. And you can tell me the actual distance. Does this make sense to you? The next thing I want you to see is what happens if they ask you what the scale factor is. They have to give you the length and the height of both things in order to ask you to do that. So here I've got an actual race car that's 132 inches long and 66 inches tall, and I've got a model of the race car that's 11 inches by 5.5 inches. Now you've got some proportions you can work with. How have I changed the length? How have I changed the height? So you're going to be looking at the numbers this way. So I've got 11 over 132. And the first question I'm going to ask is, can I reduce this? And I know, because I know my multiplication tables, that 11 goes into 132 12 times. So if I divide this by 11 and I divide this by 11, I end up with 1 over 12. Now let's check it. let's try 5.5 over 66. I also want this to equal 1 over 12. Well, if I'm going to get this to equal 1, I'm going to divide each side by 5.5. So I'm going to do 66 divided by 5.5, and I'm going to move my decimal over once, and there's my decimal. 55 goes into 66 once, 55, bring down my 0, that goes in 12. So 55 goes into 660 12 times. This also equals 112. That's my scale factor. You can use either one, but it's a good idea to use both to check your work, because as you can see, the first time I did this, I picked the wrong answer and did all of this math and figured out, oh my gosh, that doesn't work, and I had to fix it. Always check your work. You're never too old. All right, we're going to jump straight to practice, because this is all stuff that you've done before. I'm not introducing any new ideas here. I'm just having you look at proportions in like the fourth way now. So you're going to find the scale factor. I've got a grizzly bear, and I've got the doll of the grizzly bear, and the height in inches is 84 and 6, and I need you to find the scale factor. Number 2, in a photo, a sculpture is 4.2 centimeters tall and 2.5 centimeters wide. The scale factor is 1 to 16. Find the size of the sculpture. So you have both of these and the scale. So take this with the scale and find out how tall it really is, and this with the scale and find out how wide it really is. Next, you're going to get from Ashland to Portland, Jane measures 12 inches on her map. The scale is 0.5 inches to 21 miles. So for every half an inch, there's 21 miles. How far is it to Portland in real life, not on her map? So I need you to set up this as a proportion with the 12 inches and an X here, and solve for X. An artist transferred a rectangular design 13 centimeters long and 6 centimeters wide to a similar canvas that was 260 centimeters by 120 centimeters. What was the scale factor? So you're given two fractions, two ratios, and you have to find the scale factor. All right. First thing I'm going to ask you to do, hazard signs, questions. I need you to put stars by what you know. I need you to be ready for this test. Now, I know you know how to make ratios. I know you know how to solve proportions. We've been doing it like 4 or 5 different ways. I need you to be good at it. I need you to review dimensional analysis. I need you to make sure you're good with standard units and metric units. I need you to go through this chapter and make sure you're strong with it. And go through the videos that you're not strong in and review them. Take that time to get the A that you want, okay? You're getting in higher math now, and it takes a little bit of effort and a little bit of studying to make sure that you can pass these tests the first time with flying colors, okay? Good luck. Let me know if you have any questions. I'll see you tomorrow.